DARPA's UAVForge competition calls for vertical takeoff and landing aircraft that can operate autonomously for up to 3 hours of observation and 30 minutes of flight time with continuous telemetry transmissions. To complete the competition, vertical takeoff and landing aircraft power distribution must be well understood. A group of 7 students and 2 instructors at Montgomery County Community College have decided to accept this challenge. We have formed the Power Distribution Team, whose mission is to develop an open-source solution for quadrotors to augment their flight autonomy to over 3 hours without constraining their payload.
The main contribution of the MC3 team is our research and testing in the area of power distribution. The biggest problem that the typical quadrotor suffers from is the extremely limited flight time due to both the large power consumption of 4 constantly running motors and the limited charge capacity of even the best LiPo battery. The DARPA objective is to have the UAV capable of a 3-hour-plus combined flight and surveillance mission. With the average LiPo battery lasting barely 20 minutes, this is obviously not a viable option.
Our test bench's frame is that of a cross-shaped quadcopter. We chose this design because it is the design that requires the most power to stay aloft. The frame is attached to the table in a variety of configurations with the purpose of limiting the mobility of the frame.
The test equipment that our team will be using to record the data for our test bench are the Hyperon eMeter 2 and the EagleTree eLogger V4. The data that will be collected include ambient temperature, height and position, throttle, current, voltage, RPM, and watts. The use of both the eMeter and the eLogger will be vital for comparison to ensure the accuracy of the gathered data. We will also be using software called a drive calculator that allows us to view our expected results through motor analysis prior to the bench testing. We expect our flight time to be about 20 minutes with a propeller speed of 8,000 RPMs.
To achieve the desired expected results, we are confident that we must have access to testing a fuel cell. We have contacted the Air Force towards obtaining a fuel cell designed to run the Tiger UAV and use it on our test squad.